Picture a rock drifting silently through the darkness of space. Nothing special to look at, just half a kilometer wide, about 5 city blocks across. But this particular rock, known as 101955 Bennu, is one of the most important objects we're watching in our entire solar system. Why does Bennu matter so much? Two reasons stand out above all others. First, there's its age. Bennu is what scientists call a primitive asteroid. It's been floating through space, virtually unchanged, for over 4 billion years. While Earth was forming, evolving, and developing life, Bennu just existed, frozen in time. It's like a message in a bottle from the very beginning of our solar system, a time capsule carrying the story of how everything, including us, came to be. Second, there's its path. Bennu's orbit regularly brings it uncomfortably close to Earth. And because of that, there's a small but real possibility it could actually hit our planet sometime in the late 2010s. Now, the odds are tiny, but they're not zero. And when you're talking about protecting an entire planet, even tiny odds deserve our full attention. So watching Bennu closely gives us an incredible opportunity. We can learn where we came from, the ancient materials that built our world, and we can learn how to protect where we're going. Because this silent visitor from deep space is telling us a story we need to hear. A story about Earth's origins, and about the work we still need to do to keep it safe. Now, what happens when we actually send a spacecraft to visit such an object? And what can we learn by bringing a piece of it home? Let's find out. Bennu isn't just another space rock. It's a messenger from a time before our planet even existed. Go back about 4.5 billion years. The sun was young, surrounded by a massive, swirling disk of gas and dust. In that chaos, tiny grains started sticking together. Those grains became pebbles. Pebbles became boulders. Eventually, those boulders grew into the planets we know today. Bennu is one of those leftover pieces, a building block that never became part of a planet. It's remained virtually unchanged since the solar system's very first days. That's what makes it absolutely priceless. Bennu's surface is packed with carbon, organic molecules, and minerals that once came into contact with water. These are the exact same ingredients that may have sparked life on Earth billions of years ago. Many scientists believe asteroids like Bennu delivered these life-forming materials to our planet through countless impacts over millions of years. When we study Bennu, we're not just examining an asteroid, we're looking at the actual recipe that made us. Every speck of dust on its surface carries chemical clues about how planets form, how oceans appear, and ultimately, how life begins. For NASA, Bennu is essentially a time machine frozen in rock. By understanding what it's made of, we can trace our own origin story back to its very beginning, back to when Earth itself was nothing more than a possibility floating in space. In September 2016, NASA launched one of the most ambitious missions in its history, OSIRIS-REx. The goal sounded straightforward enough: travel to Bennu, study it up close, and bring a piece of it back to Earth. But as anyone who follows space exploration knows, straightforward rarely means easy. OSIRIS-REx launched aboard an Atlas V rocket from Cape Canaveral, Florida. It then spent 2 full years cruising through space, covering more than 2 billion kilometers. Finally, in December 2018, the spacecraft arrived at Bennu, and what it found surprised everyone. From a distance, Bennu had looked relatively smooth, like a dusty pebble floating in the void. But up close, it was absolute chaos. The entire surface was covered with sharp, jagged rocks and massive boulders. Some were the size of houses. Nobody had expected this. The terrain was so treacherous that mission engineers actually had to rewrite major parts of their plan while already in orbit around the asteroid. Using high-resolution cameras and laser scanners, OSIRIS-REx carefully mapped every single inch of Bennu's surface. It measured the asteroid's gravity, its rotation, even the way sunlight reflected off its dusty slopes. Every data point helped scientists build the most detailed 3-dimensional model of any asteroid in history, and Bennu turned out to be full of surprises. It wasn't the solid, dead rock they'd imagined. It was fragile, surprisingly active, and constantly releasing small bursts of dust particles into space. In its own way, Bennu was alive, reacting to the warmth of the sun as it passed by. After months of careful observation, NASA finally chose a collection site. They named it Nightingale, a relatively small flat crater near the asteroid's north pole. Now came the hardest part of the entire mission, actually touching Bennu. After nearly 2 years orbiting Bennu, OSIRIS-REx was finally ready for its most daring maneuver, touching down on the asteroid's surface to collect a sample. NASA engineers spent months rehearsing the operation, which they called TAG, Touch and Go. There would be no second chances. Bennu's gravity was so incredibly weak that even the tiniest mistake could send the spacecraft tumbling helplessly into space. On October 20th, 2020, OSIRIS-REx began its slow descent. It drifted carefully toward the surface, guided by laser sensors and preloaded maps of the terrain. At just 0.2 of a mile above Bennu, it extended its robotic arm, a specialized 3.4-meter instrument called TAGSAM. At the end of that arm was a round collection head designed to fire a burst of nitrogen gas, which would stir up dust and small rocks to capture. The moment the arm made contact, something unexpected happened. The surface didn't act like solid ground at all, it reacted more like a fluid. Bennu's surface simply crumbled. Dust and pebbles flew in every direction. For a few heart-stopping seconds, the spacecraft was actually sinking into the asteroid. Then, exactly as planned, it fired its thrusters and backed away, clutching the precious material it had collected. The entire operation lasted just 6 seconds, but those 6 seconds changed history. NASA later confirmed that OSIRIS-REx had gathered far more material than they'd hoped for, enough to completely fill the collection head. The sample was carefully sealed inside a special return capsule, protected for its long journey home. That moment, 6 seconds of contact across millions of miles of empty space, gave humanity its first physical connection to the early solar system. For the scientists watching anxiously from Earth, it was proof that with precision, patience, and courage, we really can bridge the vastness of space itself. With the precious sample safely tucked away, OSIRIS-REx began its slow journey back to Earth. In May 2021, the spacecraft fired its thrusters and gently pulled away from Bennu. For the first time in nearly 5 years, it turned its solar panels toward home. Inside the sample capsule were pieces of rock and dust that hadn't been disturbed in billions of years, matter that's actually older than Earth itself. The return trip took more than 2 years, covering hundreds of millions of kilometers through the emptiness of space. During all that time, the spacecraft stayed healthy and on course, constantly checking its instruments and running tests to make sure the capsule would survive re-entry into Earth's atmosphere. Every small correction burn had to be absolutely perfect. There was no backup mission if something went wrong. Finally, on September 24th, 2023, the moment everyone had been waiting for arrived. As OSIRIS-REx passed about 63,000 miles above Earth, it released the capsule carrying Bennu's sample. The small container sliced into our atmosphere at an incredible 27,000 miles per hour, glowing bright orange as it plummeted toward the Utah desert. Its parachutes deployed perfectly, slowing the capsule for a gentle landing at the Department of Defense's Utah Test and Training Range, the same stretch of desert where NASA has recovered spacecraft before. Scientists and recovery teams wearing protective suits rushed to the landing site. Within minutes, they'd secured the capsule and placed it in a clean room for immediate transport to NASA's Johnson Space Center in Houston. Inside that capsule was a treasure unlike anything found on Earth, the very first U.S. sample ever returned from an asteroid. For the engineers and scientists who watched it fall through the desert sky that morning, the landing marked the end of a 7-year journey across space. But it also marked the beginning of something even more important. Finally, unlocking Bennu's ancient secrets. When scientists finally opened the OSIRIS-REx sample capsule in Houston, what they discovered exceeded everyone's wildest expectations. The container held 121.6 grams of dark, fine-grained material, far more than NASA had hoped to collect. And every single particle represented pristine matter from the very dawn of our solar system, completely untouched for over 4 billion years. Under powerful microscopes, those grains revealed something extraordinary. They contained carbon, nitrogen, water-bearing clay minerals, and complex organic molecules, essentially all the fundamental ingredients necessary for life as we know it. These findings confirmed what many scientists had suspected for years. Asteroids like Bennu likely delivered the raw materials that helped spark life on early Earth billions of years ago. As one NASA scientist beautifully put it, this sample is a snapshot of the chemistry that built us. Each tiny fragment told a story written long before Earth even existed. Some minerals showed clear signs of having interacted with liquid water, proof that Bennu's parent body, the much larger asteroid it once broke off from, contained water long before Earth's oceans ever formed. Other fragments contained organic compounds that can combine to form amino acids, the very molecules that make up proteins in all living things. What made this discovery even more powerful was its purity. Unlike meteorites that crash into Earth and become contaminated by our atmosphere and environment, Bennu's sample was absolutely pristine. It was preserved exactly as it existed in the depths of space, completely unaltered. For researchers around the world, it was like opening a time capsule that had been sealed since the beginning of the solar system itself. And for all of us, it was a profound reminder that the story of life on Earth may have actually started far away from our planet, carried across the vastness of space by ancient rocks like Bennu. Even after revealing its secrets, Bennu remains far from harmless. It continues to orbit the Sun along a path that periodically brings it dangerously close to Earth, close enough that NASA officially classifies it as a potentially hazardous asteroid. Using all the data gathered by OSIRIS-REx, scientists have now mapped Bennu's orbit with remarkable precision. They've even calculated how sunlight itself can gradually change the asteroid's path over time through something called the Yarkovsky effect, a subtle force that occurs when the sun heats one side of a spinning asteroid, causing it to slowly drift in a particular direction. That level of precision led to a sobering calculation. On September 24th, 2182, about 158 years from now, Bennu has roughly a 1 in 2,700 chance of actually colliding with Earth. Now, that probability might sound extremely small, but in astronomical terms, it's significant enough to plan ahead. If Bennu were to hit our planet, the impact would release energy equivalent to more than 1 billion tons of TNT, absolutely devastating on a regional scale, potentially affecting an entire continent. That's exactly why NASA and other space agencies monitor its trajectory so carefully. The OSIRIS-REx mission wasn't just about collecting a sample for scientific study. It was also about learning how to protect our planet from potential threats. By thoroughly understanding Bennu's size, shape, rotation, and surface composition, scientists can now create accurate models of how such asteroids move through space, and most importantly, how we might deflect them away from Earth if it ever becomes necessary. This knowledge could prove crucial for future missions, specifically designed to nudge dangerous asteroids off their collision course long before they ever pose a real threat. Bennu's existence serves as both a warning and a valuable lesson. It shows us that our universe is dynamic, unpredictable, and deeply interconnected. And it proves that with careful planning and advanced technology, humanity can do more than simply observe the cosmos from a distance. We can actively defend our place within it. With its precious sample safely delivered to Earth, OSIRIS-REx's primary mission was technically complete. But the spacecraft's story didn't end there. Instead of being shut down, NASA gave it a new name and an exciting new purpose. It's now called OSIRIS-APEX, which stands for Apophis Explorer. The spacecraft is currently traveling toward another asteroid called Apophis, which will pass extremely close to Earth in 2029, closer than many of our communication satellites. What began as a mission to understand one asteroid has transformed into an ongoing journey to understand how near-Earth asteroids evolve and interact with our planet's gravitational field. Meanwhile, back here on Earth, the real treasure remains in our laboratories. At NASA's Johnson Space Center in Houston, scientists are carefully cataloging Bennu's material and distributing small portions to research teams all around the world. Some of those precious grains will be studied for decades using tools and techniques that don't even exist yet. Others will remain carefully sealed away, preserved for future generations of scientists to explore with technologies we can't yet imagine. Each fragment represents a genuine scientific time capsule, an irreplaceable gift from a world that's remained virtually untouched for more than 4 billion years. But Bennu's story isn't only about science and discovery, it's about gaining perspective on our place in the universe. From a small asteroid floating 500 million kilometers away, we've learned just how fragile and precious our own world really is. We've learned that the very same cosmic forces that could potentially threaten Earth are also the forces that created it in the first place. And we've proven that human curiosity, that simple, powerful drive to understand more about our universe, can literally carry us across the void of space and bring distant worlds closer than we ever thought possible. As OSIRIS-Apex continues speeding toward its next target, Bennu remains behind, continuing its ancient orbit around the Sun, silent, unchanging, and in its own way, still watching over us. The mission may be officially over, but its legacy continues to orbit alongside our planet, reminding all of humanity that in the vast emptiness of space, even the smallest rock can change absolutely everything.